Okay, now here we have this example, and we have 1,346 miles. Part A, if the trip took 20.9 hours of driving time, estimate the average speed in miles per hour. So miles per hour that the car traveled. We have miles per hour. And how many miles we have is 1,346, and over we have 20.9. It didn't ask us how to run it, so let's practice here. And I'm gonna run this to nearest hundred. This is ones, 10, hundreds. So to nearest hundred, this is 1,300. And denominator, I'm gonna run it to nearest whole. So it's the answer is without having decimal point is 21. After dividing with 61.9, this is the answer. Again, we can run it to nearest whole. The nearest whole is 62. Part B, if the car used 63 gallons of gasoline, estimate the average gas mileage of the car in miles per gallon. So what we have is 1,346 miles. And here we have 63 gallons of gasoline. Again, I'm doing the same thing as that one, running it, each one separately first. I'm going to run this to nearest 100, so 1,300, and this one is using front end running, or we can say that I can run to 10, so nearest 10, meaning that you have 60. I'll try all of this for practice. Now I'm dividing, here is 21.66. Again, I can run it to nearest whole. I don't want to have that decimal point, so it's 22. If the cost of gasoline averaged $3.99 per gallon, estimate the total cost of the gasoline used. Estimate running that one to nearest dollar. We have $4 multiplied by here we had 63 gallons, and again, using exactly the same that I did in part B, I rounded to nearest 10 or use front end running. So that is equal to $240. Now, example number 4, estimate the difference in the values of $50 and $50 and 100 Mexican pesos. Assume that 1 peso is about 0.067 $. So 1 peso is this much. And since we want to compare with 100, so here is 100 peso. So that is equal to, we have to multiply that one by 100, so this is 6.7. Meaning that is $6.70. We can directly run that one here to have $7 instead of this, or we can run at the end. So let's run at the end. So estimate the difference between $50 and 100 pesos. $50 minus, this is 100 pesos and that is 6.7, so it's $6.70, and that is equal to $43.30. Now estimate that one, that is $43. I round it to the nearest dollar. Even if you run this one, this would be $7, and 50 minus 7 again is $43. So I didn't use that one, but if you round here, again you have same answer. So, or using that one, then this way you're gonna have $50 minus $7. So this is estimate because I already run this one here on the output. Again, the answer is 43. For example number 5, here business has 4,157,372 okay, so in sales for the year. Use it to estimate the following. Okay, so sales is $4,157,372. And here we have 6 parts here in this pie chart. So this 9% is, this one is dollars. Okay. I'm going to write all of these. This one is AR. Seattle and Dallas, and this one Denver. Now, how much of the company sell came from New York City? So for New York, we have 15%, meaning that we should multiply this number by this number that we have in sales. So here is 15% of sales is 4,157,372, and here we have to estimate for all of these because we have this one. For the reason of rounding these two numbers, so I'm running that one using front end rounding or rounding to near sum. This is 20% off. I'm using front end rounding. This is $4 million. I'm using that word. They have is as 20% multiplied by 4 million. That is equal to $800,000 in sales for New York City. Now, how much of the company sales came from Chicago? Well, for that part, we have here is 24%, exactly same as this, for 24% of $4,157,372. But we have to run it exactly same way that I did here. So it's 24% of so here is 20% of $4 million. So the answer is, since I run it, here we have 20% multiplied by 4 million. I'm not using that dollar sign here. So 4 million, that is equal to, at the end I'm using dollar sign, so this is again same answer, $800,000. Now, how much of the company sales came from Seattle? And for that part, we have 28%. The 28% off. Again, same method. Rounding. I'm rounding that one to your cents, and this is 30% off. For this one, again, front end rounding, we have $4 million. So we rounded, and instead of that, I'm converting to this one number, 30% multiplied by 4 million. And the answer is $1,200,000. Now, example number 6. The following shows Jessica's monthly budget this year. And the second column here, we have month allocated, and the third one is amount she spent. About how much does Jessica spend each month? What that means, we need to add all of these, but it says about how much we have to run these. So run all of these. I'm running to your cent, so that is 60. Here is 120. Here is 150. 100. 30. 80. This is 0. And here is again 30. So add all those numbers with the answer for this part. So I added all these. We have 8 numbers. Estimate is $570. Now part B, determine her daily spending by dividing part A by 30. So dividing that one by 30 to find her daily spending. So we have $570 divided by 3 days. And that is $19 a day. Now, Parsi, the average American spends $75 per day. How does Jessica's spending compare with the average Americans? So comparing. We have $75 average, but for her we have $19. That is equal to $56, meaning that she's saving $56 daily compared to the American average. So she saves this much daily. Compared to the American average. So, average Americans. Now, example number 7, estimate the total time it would take to spend $1 million. Here we have $1 million. If you spend $1 per second, so this is clear that if you spend $1 per second, meaning that you have to spend 1 million seconds. Okay. Now calculate the exact amount of time it would take. How close was your answer? So this is for fun, because this is easy to find. What we have for exact, since we have $1 million and we have $1 per second, that means that we have 1 million seconds. So this is what exact is. Now, I want to convert this to days and see how many days we have, because I want to find what the estimate is. This is $1 million, and I'm not able to estimate that one, so instead of considering seconds, I'm going to work on days. Convert $1 million seconds to days. We can convert that. Here on top we have 1 million seconds. And here we have, since I have second on that part, I should have second here. And this says 1 minute is equal to 60 seconds. Multiplied by 1 hour is equal to 60 minutes. And finally, 1 day is 24 hours. Now we can divide these, so simplify all these. We have second, minute, hour divided by hour. So what's left here? On top we have 1 million times 1 times 1 times 1 day. And the denominator 1 times 60 times 60 times 24 is 86,400. And after that divide, here is 11.574741. I wrote what I got on calculator. And after that, running it, since I'm gonna have days, meaning that we have to run two whole numbers, and that is 12 days. So here what we had was that number, and after running was 12 days. This is the difference that we have between estimate and what the answer was. So it's less than 1 day.